Listen, the next topic is homogeneity of dimensions. In the previous class, we studied dimensions, distance, denoted by distance under category length, understood? M, L, T, like that. We studied in the previous class. The next is homogeneity of dimensions. Homogeneity of dimensions means, suppose I have a formula. I have a formula, say P equal to A plus B. Suppose I have a formula that P equal to A plus B. Then we can say that the dimensions of A must be equal to dimensions of B. If we have a formula that sum or difference of two numbers, if we have a formula that sum or difference of two numbers, then what we can conclude? A and B must have the same dimensions. I will give you example. Don't worry. I will give you example. I have a formula. I have a formula that P equal to A plus B or A minus B. What I can say that the dimensions of A must be equal to dimensions of B. The physical quantities having same dimensions can be added or subtracted. The physical quantities having different dimensions cannot be added. I will give you example, but let me write it. It's a standard result. I will give you example. What I am saying is, the physical quantities having same dimensions can only be added or subtracted. For example, can I add 2 meter and 20 degrees Celsius? Can I add? Is it meaningful? Is it meaningful? 2 meter plus 20 degrees Celsius. Is it meaningful? Rakshana, you please tell me. It does not have meaning. No formula contains terms like this. The 2 meter and 20 degrees Celsius, both of them having different dimensions. 2 meter belongs to the dimension L. 20 degrees Celsius belongs to the dimension temperature. They have different dimensions. This belongs to the category L, length. This belongs to the category temperature, Kelvin, denoted by K. I explained in the previous class. They have different dimensions. The quantities having different dimensions cannot be added. So no formula contains numbers like this. At the same time, 2 meter plus 7 meter, it is possible because it can be added, because it will be 9 meter, because the addition or subtraction will be possible. Here both of them having same dimension. 2 meter dimension L, 7 meter dimension also L. So what I am saying is, addition or subtraction possible only if the quantities having same dimensions. If the quantities having different dimensions like this, it cannot be added, or addition will be meaningless, understood? For example, 2 meter plus 17 kilogram, it is meaningless. I cannot add the distance with the mass. The distance plus mass, it is meaningless because they have different dimensions. 2 meter belongs to the category L, length. 17 kilogram belongs to the category mass. They have different dimensions. So my conclusion is simple. The addition or subtraction possible only for those quantities having same dimensions. I have a formula, suppose I have a formula that P equal to A plus B or P equal to A minus B. What we can say? Dimensions of A equal to dimensions of B equal to dimensions of P. Because 2 meter plus 7 meter, it is 9 meter. 9 meter is also L, length. So this is a standard result you have to memorize. Okay, so this paragraph is talking about this result. Let me read it. After explaining this paragraph, the magnitude of physical quantity may be added together or subtracted from one another only if they have same dimensions. I explained. In other words, we can add or subtract the similar quantities. Velocity cannot be added to the force. They have different dimensions. Or electric current cannot be subtracted from thermodynamic temperature. So this principle is said to be principle of homogeneity. Okay, understood. It's very important. Okay. So, question. Verify. Check the following equation is dimensionally correct. Dimensionally correct. This type of question is very, very important. Actually, this is taken from textbook. Check the following equation is dimensionally correct. I will explain that. V equal to U plus AT. We studied that in motion along a straight line. We have studied that. V equal to U plus AT. We have to prove it. I mean, this is true. Dimensionally speaking, it is true. This formula is valid. V is the final velocity of the body. U is the initial velocity. A is the acceleration. You have already studied that. And T is the time. So we have to prove that V equal to U plus AT is this formula is dimensionally correct. How will you verify? I will tell you. You just prove that the dimension of left hand side is equal to dimension of right hand side. The equation, suppose we have an identity, then dimension of left hand side must be equal to dimension of right hand side. So, and let me explain one more result. Some important results I would like to discuss without any proof. Some important, before that let me explain some important results. Let me discuss that first. Dimension of A plus B. Dimension of A plus B. A and B are two physical quantities. Dimension of A plus B is equal to dimension of A plus dimension of B. Actually, it is obtained from this formula. Okay, anyway, leave it. Dimension of A plus B. Sorry. 1 minute. Listen. We have to prove that V equal to U plus AT. Correct? What is the dimension of V? What is the dimension of LHS? Aryan, ഒന്ന് പറഞ്ഞേ. Aryan കഴിഞ്ഞ ക്ലാസ്സിൽ ഉണ്ടായിരുന്നല്ലേ. What is the dimension of velocity, Aryan?
Yes, sir.
Don't remember. Nadasha, what is the dimension of velocity?
Sir, L1 t minus 1.
Yes. L1 or LT raised to minus 2. I specifically told you that you must memorize the dimension of velocity. Dimension of velocity is LT raised to minus 2. Deva, Rakshana, do you remember this? Deva, Rakshana, do you remember this?
Yes, sir.
Yes. Now right side. So left side has the dimension LT raised to minus 2.
T raised to minus 1.
Okay. LT raised to minus 1. Sorry. This is the acceleration. Sorry. LT raised to minus 1 is the dimension of V. Now, so dimension of left hand side. let me write like this. Dimension of LHS, it is V, it is L t raised to minus 1. Now I am going to find the dimension of RHS. What is the dimension of U? It is initial velocity, right? Dimension of U, it is the initial velocity. Still it is velocity. Initial velocity is also a velocity. Dimension is L t raised to minus 1. Now I want, so dimension of V I got, dimension of U I got. Now let me find out dimension of AT. If there is product, consider it as a single term. If there is product, consider it as a single term. Dimension of AT. Dimension of AT I am going to write. Dimension of A. A is acceleration. What is A? A is acceleration. Anybody? Rakshana, you please tell me what is dimension of acceleration? Rakshana, you were present in the last class?
Yes, sir, I was.
You forgot.
But like I was late on.
Okay. If you have any doubt, you please ask me, Rakshana. Okay. If you don't understand, please ask right now. Okay. Acceleration has the dimension L t raised to minus 2. Acceleration has the dimension L t raised to minus 2. If you don't understand, you can ask me, I will explain. Acceleration has the dimension L t raised to minus 2. T stands for time. Time has the dimension t or t raised to 1. Time has the dimension t or t raised to 1. So L into t raised to minus 2 into t raised to 1. T raised to minus 2 into t raised to 1. So remember, if there is product, you have to consider it as a single term. It is very important. So dimension of AT to be written. Dimension of each term you have to write. When the plus or minus is involved, each terms must have the same dimension. If there is plus or minus exist, each term must have the same dimension. Why? Reason is this. P equal to A plus B or A minus B. See that each term has the same dimension. Dimension of P same as dimension of A, same as dimension of B. This is homogeneity. So if there is plus or minus involved in any formula, the dimensions of each term must be identical. If there is product, you have to consider it as a single term. So I have to verify that each term has the same dimension. V, what is the dimension? L t raised to minus 1. U, what is the dimension? L t raised to minus 1. AT as a single term. Dimension of AT also L t raised to minus 1. Each terms. So conclusion, you have to write that dimension of each terms are identical. If there is plus or minus involved in any formula, dimensions of each term must be identical. The product term must be considered as a single term. So you have to write at the like this. Hence the given formula is dimensionally correct. Understood? The given formula, we have to write the conclusion like this. The given formula is dimensionally correct. Okay, we can verify whether the formula is correct or not using a dimension principle. Okay, so all of you please write and ask your doubt. Okay, just write a note. A constant does not have any dimension. A constant, constant means examples like 2, 3, 1/7, like that. That is constant. A constant does not have any dimension. A number like 2, 3, 1 by 2 like that does not have any dimension. Okay, I will give you example, don't worry. So you please write this one as note. 2, what is the dimension of a number 2? No dimension, understood? But if there is 2 meter, okay, it will be length. But no unit. A constant does not have any unit. A constant does not have any unit, does not have any dimension, understood? A constant without a unit, understood? Without a unit. A constant without any unit does not have any dimension. 2 meter has the dimension length, but 2, just a number 2, does not have any dimension. Clear? Okay, understood? Nadasha?
Yes, sir.
Another question. Let me discuss another question. Check if the following equations dimensionally correct. Check if the following equation is dimensionally correct. S equal to ut plus half a t square. You are familiar with this equation. Is it correct? Rakshana, Nadasha, Deva, is it correct? You are familiar with this equation. So, the plus or minus are involved. We have to prove that dimension of S will be equal to dimension of ut. If the product is there, consider it as a single term. If the product is there, consider it as a single term. So this highlighted quantities must have the same dimension. If plus or minus involved in any formula, each quantities must have the same dimension. The quantities having different dimensions cannot be added. So each quantity, each highlighted terms must have the same dimension. So let me find out dimension of S. I will ask you question. Deva, please tell me what is the dimension of S?
Sir, it is length.
Length, very good. Okay, dimension of S is length. So this one is done. The next is dimension of ut. Next is dimension of ut. I will explain that. U is the initial velocity. I told you in the previous class, velocity and acceleration, dimension of velocity and acceleration, you have to memorize. U is the velocity which has the dimension L into t raised to minus 1. And t is the time, has the dimension t. T or t raised to 1, both are same thing. If you multiply, L will be there, but t raised to power should be added. Minus 1 plus 1 will be 0. You have to write all the steps. Don't skip any step. Minus 1 plus 1 will be cancelled. Studied in the lower classes that the power 0, then it will be 1. If the power is 0, it is 1. L, okay, L. So ut has the dimension L. Now half at square is remaining. Dimensions of half at square. Half is just a number, does not have any dimension. We need not write it. Half does not have any unit. So one half does not have any dimension, we will not write it. A is the acceleration. In the previous class, we studied that a acceleration has the dimension L into t raised to minus 2. You memorize acceleration velocity. T square is that, t square. T square is, okay, t square itself. L into t raised to, the powers should be added. T raised to minus 2 into t square. Minus 2 plus 2 will be 0. T raised to 0 1, correct, L. This one also found. So this is the dimension, homogeneity. Plus or minus is the, everyone must, each terms will have the same dimension. So each highlighted terms must have the same dimension. So your conclusion is dimension of S is equal to dimension of ut is equal to dimension of half at square. So the given formula S equal to ut plus half at square is dimensionally correct. Dimensionally correct. Try this question. Check if the equation, if the following equation dimensionally correct or not. V square equal to U square plus 2AS. Actually this formula, you studied it, it is true. Actually we have to verify that in terms of dimension it is true. Okay, so you place
Yes.
V is LT raised to minus 1 squaring L square T raised to minus 1 square T raised to minus 2. So V square is done. Same way U square, same thing. U is also velocity, just copy. Just copy. L square T raised to minus 2. Now 2AS. 2AS, 2 does not have any dimension. A is acceleration, L T raised to minus 2. S is displacement, L. L into L, L square. L square T raised to minus 2. Deva, all of you clear? Deva, Nadasha, okay. Aryan, Aryan മനസ്സിലായോ? Aryan,
Yes, sir. From
Deva, do you have any doubt? Deva.
No, sir, I understood.
So dimension of each terms are correct. I suggest you may write one more step, but in some books one additional step is written. That is why after this you may write, add this also, dimension of LHS is equal to dimension of RHS. Actually this is sufficient, but you may add this step also. Dimension of left hand side L square T raised to minus 2, right hand side also L square T raised to minus 2. So dimensionally correct, dimensionally valid. Correct. So you please write down. All of you clear? Aaron, Rakshana, Deva, Aryan, Nadasha.
yes, sir.
So you please write down. Okay. There are questions in solved example. I will discuss that. I will read it. Let us consider an equation. Actually this equation you will learn in the chapter work energy power. This is actually a formula you will learn in another chapter, work energy power. But here I want to verify dimensionally it is true. So let us consider the equation. M is the mass, V is the velocity, G is the acceleration due to gravity, H is the height. Everything is mentioned. Check whether this equation dimensionally correct or not. So left side no plus, so you just find out a dimension of left hand side, dimension of right hand side. Just verify the left side and right side are equal. No plus is there, so we need not worry about that. So dimension of left side, dimension of LHS, or dimension of half mv square. All of you please listen. Dimension of half mv square is, half does not have any dimension. A number without any unit does not have any dimension. M is mass. Studied yesterday, previous class, mass has the dimension capital letter A. Now v square is there. V is the velocity, clearly mentioned in the question. Velocity has the dimension L t raised to minus 1. But square is there. Okay, square is there. V square, understood. So m into squaring each terms L square. L square into t raised to minus 1 all square. In that case, multiply the power. T raised to minus 1 all square will be t raised to minus 2. You may write 1, m and m raised to 1 both are same. Till next is right hand side. Dimension of mgh. M is the mass. M is what? Mass. G, what is this G? G is the acceleration due to gravity. A falling body will have an acceleration. That is G. Acceleration has the dimension L t raised to minus 2. I told you to memorize that. Acceleration, whatever may be the acceleration, whatever type of acceleration may be, acceleration has the dimension L t raised to minus 2. H is the height mentioned in the question. H is the height. Height is L. Height is length. So m is the L into L is there. L into L. What is this L into L? L square. T raised to minus 2. T raised to minus 2. So dimension of LHS is same as dimension of RHS. So the given equation is dimensionally correct. You may write that, okay? That given equation is dimensionally correct. So you please write down, and if you have any doubt, please ask. Nadasha understood, Deva, Aryan.
Yes, sir.
If you have finished, please raise your hand. If you have finished. Deva completed. I will give you homework. After the class, I will give you homework, okay? നഡാഷയ്ക്ക് homogeneity doubt ഉണ്ടെന്ന് പറഞ്ഞു. Clear ആയോ ഈ question, നഡാഷ?
Yes, sir.
So the dimensional analysis is over now. Dimensional analysis over. Let me discuss one more question. Today, by today's class, the dimensional analysis will be over, okay? I will discuss more problems, okay, next class. And okay, in 2 classes or 1 or 2 classes, this chapter will be over, okay? So can I go to next page? Hello, finished? Now Rakshana, Aryan, Aaron, completed?
Yes, sir.
Okay.
Yes, sir.
Actually, the question I am going to write, it is already there in NCERT, but the question style is different. Question style is different. But let me write. Check. So not check. Show that the following. It is a tough question actually. Equation T equal to, this formula you will learn in another chapter. There is a chapter oscillation. There is a chapter oscillation. You will learn this formula in the chapter oscillation. But here we just want to verify this formula. Okay. L by G. This is very important question. Show that the equation time t. I will explain each letter. Don't worry. T equal to 2 pi into root of L by G is dimensionally correct. Dimensionally correct. Where all the letters will be mentioned. Don't worry about that. T is the time period. I will discuss that. Actually, you will learn this formula. Okay. You will learn this formula in another chapter oscillation. Time period of the pendulum. Time period of the pendulum. L is length of pendulum. Length of pendulum. And G is acceleration due to gravity. Acceleration due to gravity. We have to verify that this formula is dimensionally correct. I will explain that. Actually, this is about the oscillation. I mean simple pendulum. Don't worry about that because you will learn in another chapter. Pendulum, you have already heard about that. Pendulum. This is the length of the rod. At the bottom there is a small knob. Okay. Initially, if I provide a small displacement, what happens? It will oscillate like this. To and fro motion is actually said to be oscillation. You have seen that pendulum will be moving like this, to and fro, continuously moving like this. Time period is actually that knowledge is not required in this problem, but let me discuss that. Time period is, suppose initially the pendulum is here. The pendulum goes to the other extremity and return. Go to the other extremity and return to the initial state. The time taken for this is said to be time period. Initially, suppose the pendulum is here, it go to the other extremity or other end and return and reaches the initial position. The time taken for this motion is said to be time period. The time taken to reach the initial position. Understood? That is said to be time period. Is that okay? All of it clear? Understood?
Yes, sir.
And L is the length of the pendulum. Mentioned in the question. It will be mentioned. Don't worry. L is the length of the pendulum. We need only dimension. Okay. So I am going to verify that this formula is dimensionally correct. So we need to prove that LHS, dimension of LHS is equal to dimension of RHS. Plus minus are not involved here. Dimension of T. Dimension of time period. Nadasha, you please tell me what is the dimension of T? Time period. Time period.
T1.
Time itself. Understood. Time period means time taken. Time taken, time itself. Clear. It is the fundamental unit. Clear. Length has the dimension capital L. Time has the dimension capital T. Understood? Nadasha? Clear?
Yes, sir.
Time period is time itself. Second. Unit will be second, but dimension will be capital T. So left side has the dimension T. Now dimension of RHS. ആര്യന് മനസ്സിലാവുന്നുണ്ടല്ലോ അല്ലേ? ആര്യൻ ക്ലിയർ ആവുന്നുണ്ടോ? ആര്യൻ
Yes, sir.
2 pi root of L by G. Aryan, please tell me what is the dimension of 2 pi? Aryan,
Uh, Sir, I don't know.
you don't know. Then anybody, what is the dimension of 2 pi? Anybody? Then I will discuss that. 2 pi is a does not have any unit. Pi is 3.14. We know that. Is it a constant? Pi is a fixed number. Is the unit of pi centimeter, meter or degree Celsius? No. Pi does not have any unit. അല്ലേ ശരിയല്ലേ pi does not have any unit. Pi is simply 3.14. That's all. No unit for pi. It's not centimeter. It is not degree Celsius. Nothing. So this 2 pi does not have any unit. We need not write it. We need not write the dimension of 2 pi. A constant without any unit will not have any dimension. The root is there, should be written. L. L is length. L is what? Length. Numerator is length has the dimension L, should be written inside the square bracket. G is acceleration, right? Acceleration has the dimension L into t raised to minus 2. ആര്യന് മനസ്സിലായോ ആര്യൻ ശ്രദ്ധിക്കുന്നുണ്ടല്ലോ അല്ലേ ആര്യൻ
Yes, sir.
So you see that L into t raised to minus 2, this L cancel. Denominator is L into t raised to minus 2, L cancelled. Root is the root 1 by t raised to minus 2. T raised to minus 2 is the, actually this t raised to minus 2 is written as 1 by t square. If you don't understand, I will explain that, because this I will discuss. Don't worry about this square bracket. I explained in the previous class that a raised to minus n is 1 by a raised to n. A raised to minus n is 1 by a raised to n. So t raised to minus 2 is 1 by t square. So 1 by 1 by t square. Understood? 1 by 1 by t square. Taking reciprocal, 1 into t square by 1. Why? Because division you have to multiply with the reciprocal. 1 cancelled. Square root of t square is t. Square root of t square is what? T. So dimension of LHS. Dimension of LHS is equal to dimension of RHS. So the given equation or formula is dimensionally correct. So you please write down. If you are okay, 100% okay and finish writing, you please raise your hand. If you don't understand, please ask. Deva, you understood? Deva?
Yes, sir.
Rakshana understood. Rakshana.
Yes.
Aaron, you finished. Okay. So the dimension analysis is over. So dimension is over. Okay. So no need of any theory. Let me discuss this. The dimension analysis is over now. The conversion of units. How will you convert 1 kilogram meter square per second square into gram centimeter square s raised to minus 2? Deva, do you know kilogram to gram? How will you convert? Deva, do you know that? Kilogram to gram. Yes, correct. Nadasha, how will you convert meter to centimeter?
Sir,
Meter to centimeter, how will you do the conversion? Meter to centimeter.
1
1 meter equal to how much centimeter? 1 meter.
meter.
Tell me, 1 meter is equal to how much centimeter?
100.
100. Okay. You know the basic things like 1 kilogram is equal to 1000 gram. And 1 meter is equal to 100 centimeter. You know that. There are other conversions. I will discuss it later. Today, let me just complete this question. The conversion of one unit to another unit. These type of questions are remaining. To convert to this type, I will discuss. 1 kilogram meter square s raised to minus 2, isn't it? We can write like this: 1 kilogram into 1 meter square into 1 s raised to minus 2. We can write like this. Why? Because 1 into 1 into 1, 1 itself. Correct? 1 into 1 into 1. How many times, whichever number of times you multiply 1, you will get 1. So you have to write split like this. If there is a unit like this, you have to split like this. If you multiply 1 any number of time, you will be getting 1 itself. So 1 kilogram meter square s raised to minus 2 is written like this: 1 kilogram into 1 meter square into 1 second raised to minus 2. This must be the first step. All of it clear? This step is clear? Understood? Hello?
Yes, sir.
Hello, Deva, understood? Deva, Rakshana, have you understood this step?
Yes, sir.
Okay. We must split like this. Okay, we must split like this. In the next step, 1 kilogram. You just look at left side and right side. Right side, I want gram. I want gram in the right side. So 1 kilogram is 1000 gram. 1000 or 10 raised to 3. Correct. 1 meter square. I will explain that. 1 meter is equal to 10 square centimeter. 100 centimeter in right side you may write it. Is it correct? 1 meter is 10 square centimeter. You studied that. But I want 1 meter square. 1 meter square, just squaring both sides. Just squaring both sides. If you square left side, 1 square meter square. If you square left side, you have to square right side. 10 square all square. If you square both sides, left side will be 1 meter square, right side will be 10 square all square. 10 square all square will be 10 raised to 4 centimeter square. I will explain, I will repeat, don't worry, but listen carefully. So squaring both sides, 1 meter square will be 10 raised to 4 centimeter square. I want centimeter square in the right side. So 1 meter square is how much? 10 raised to 4 centimeter square. This one I don't want to convert, because s raised to minus 2, s raised to minus 2, both are present in the left side and right side. So the third time I don't want to make any modification. So the numbers can be multiplied separately. The numbers can be multiplied separately. 10 raised to 3 into 10 raised to 4. The powers should be added. Powers. 10 raised to 3 into 10 raised to 4, 10 raised to 7. The units after that. Okay, gram centimeter square s raised to minus 2. So it was the filling the blanks question. So the number should be 10 raised to 7. Okay. So I will discuss more problems in the next class similar to this. Okay. Nadasha, Deva, all of you clear? This question is okay?
Yes, sir.
Yes, sir.
So you please write down. If you are okay, you please raise your hand. Don't leave the class. If you are 100% okay, please raise your hand. Okay, all of you clear? Then let me wind up the class. I think by next class this chapter will be over, but I will take one extra class. Aryan, sorry, not Aryan. Aaron, you may send the additional questions. You have another book, right? You please send it
Okay, sir.
that questions. Okay, let me wind up the class. Okay, bye.
Thank you, sir.
Okay, sir. Thank you, sir.
Okay.
Bye, sir.
Thank you, sir. Bye.
Okay, bye.